Welcome back. Talking about our bonding, we're going to spend this topic and the next one talking a bit more about the ionic bonding. You remember ionic bonding? It's what happens when we have a large electronegativity difference in the two atoms that want to come together and bond. So we're talking about electronegativity differences 1.7 or greater usually, or sometimes on that grey area. Electronegativity, remember, is a measure of how much an atom wants to take electrons when they're forming a chemical bond. So in an ionic bond, we've got one atom that wants those electrons a lot, another one that not so much. So it's essentially give and take of electrons between the two in order to form that chemical bond so that they both have an octet, so that they both have that stable 8 valence electrons. It usually occurs, if you look at your periodic table, when we have a metal trying to bond to a non-metal. So that's a good way of recognizing it. If we want to understand ionic bonding, it's really high time we spoke about ions. So to introduce ions, I'm going to take another element from your periodic table, another halogen. We'll look at fluorine. So here I have fluorine, element number 9 on your periodic table. It's an atom, like all of the other atoms straight off your periodic table. It's neutral. 9 positively charged protons in the middle, 9 negatively charged electrons orbiting around the outside. If you have a close look at that diagram of fluorine I've got there, it has 7 valence electrons. That makes sense, it's from group 7 on your periodic table. So it really wants one more electron. So it's going to bond with whatever atom is willing to give it that one more electron. When it does that, it will have 8 valence electrons. It will be happy. But that means our charge balance has changed. We've now got 9 protons in the middle, in the center of the nucleus, and then orbiting around the outside, we have 10 electrons. We have one more electron than we do protons, and that means that our fluorine has changed. It has now developed a negative charge because there is one extra electron. To show that, we put a little negative sign up the top right corner next to the elemental symbol. So here I've got fluorine with a negative charge. We call this charged atom an ion. More specifically, because this one has a negative charge, we call it an anion. So, quite a few terms we've covered there, just quickly recapping. What's an ion? It's a charged atom. If it's negatively charged, it's got more electrons than protons, we call it an anion. And fluorine has also now changed its name. Now that it's an ion, we change the ending of the anions from fluorine to fluoride. So I would call this the fluoride anion. Make sense? Let's try it for the other half. Let's try it for a material that doesn't want to gain an extra electron but wants to lose some. We're going to have a look at magnesium. So here I've got a magnesium atom. It has 12 protons, 12 electrons. It's originally electrically neutral. And then as we look at the atom, we can see that in that outermost shell, it has 2 valence electrons, being in group 2. It would really love, the easiest way for it to get back to having 8 valence electrons, it would love to lose those 2 electrons. And in doing so, it'll empty that last shell. It will disappear, which means there will now be 8 valence electrons, 8 in that outermost region. To do that, it's lost 2 electrons. 12 protons, still in the nucleus, but now only 10 electrons. So this means that we have developed a positive charge. Specifically, we've got 2 more protons than electrons, so we will have a 2 positive charge. We show that in the same fashion with a number at the top right corner of the element. So we've now got magnesium 2+. This is a positively charged ion. We call this a cation. Unlike the anions, the name of the cation doesn't change, so we would just call this a magnesium cation. So, ions, charged atoms. Positively charged ions are called cations, negatively charged ions are called anions. A little bit of an aside, you and I have something very, very serious to talk about. I've been exploring this for quite some time now. I put my students to the task every year and I haven't come up with much yet. I put it to you, there is really no such thing as a good, punchy, one-liner chemistry joke. There's not. They are all terrible. One of the most famous ones relates very, very heavily to what we've just been discussing. There are 2 atoms walking down the street. One trips over the curb and gets a bit of a bump and sort of a bit of pain. The other one leans over and says, "Are you okay?" And he says, "Oh, I don't know. I think I lost an electron." "Are you sure?" "I'm positive." They are terrible. If you think you can find any good chemistry jokes, head down to the discussion forum, post them for everyone to see. The challenge is out there. But for now, Let's get back to our content. So we've got these ions, these cations and these anions, and we've looked at how they might form when an atom gains or loses electrons. There are also situations where we have a group of atoms, not just one atom, but a group that all get together, share electrons, and they also gain or lose a couple extra from somewhere else, and in doing so, they form ions. We call these polyatomic ions. Let's break that word down. Poly, meaning more than one, atomic, meaning atom, so more than one atom joining together to form an ion. And they tend to look something like this. So I've got 4 examples here for you. The first one, we've got carbon and 3 oxygens joined together, and when they all get together like that and group together, overall they have a charge of 2-. I've also got phosphate, nitrate and sulfate there for you on the list so you can see some of these polyatomic ions. It's good for us to know of their existence and know that they're around as well. You may even have heard of some of these chemicals in your day-to-day activities. For example, you can find carbonates in your kitchen in washing soda. You can find phosphates in your detergents. So I imagine some of these names might be familiar to you from other walks of life. Now, chemistry is a language, and if you've learned any other language, I'm sure you've had the same difficulties I have, which is to say that as much as you might learn about the structure and nature of the language, until you know the vocabulary, things can be very, very challenging. And chemistry is the same. For people who are taking chemistry for an extended period of time, we need to learn the vocabulary. And what that vocabulary usually entails early on is a list like this, a list of common cations and anions that form. So I would normally ask my students to learn the names of these ions and the charges they like to form, and we go to great lengths to try and do this. I've even tried reading the table to them and recording it so they can play it to themselves on the train, wherever the case may be. Probably just ends up putting them to sleep, but wherever the case may be. We've tried writing songs for them. Really important to get this vocabulary down. Because of the nature of our delivery here, I'll handle it a little bit differently. I've placed this table for you in the additional resources area. I don't want you to memorize it, but it will be worth printing it off or downloading it, keeping it nearby. It's going to be really helpful for you in our very next topic when we start putting these ions together to make ionic compounds. So do make sure you've got that one handy. So wrapping up today's content, what have we covered? We've discussed ions. Ions are, once again, they are charged atoms. If we have a positively charged atom that's lost electrons, we call that a cation. If we have a negatively charged atom that's gained electrons, we call it an anion. And our next topic, we're going to start putting these cations and anions together and making real everyday materials that you see all around you.